So we come now to one of those other hidden L'Hopital's rule forms. What we have here is the limit as x approaches 0 from the plus side of x times ln of x. Notice, by the way, that it's necessary to say that we're approaching from the positive side because there is no such thing as the natural log of either 0 or a negative number. So anyway, if you look at what's going on here, the ln function, of course, looks like this. So as I approach 0 from the positive side, ln x is approaching negative infinity, and x is, of course, approaching 0. So what I actually have here is the form, um, I have the form 0 times infinity. So the question is, why is this in a, first of all, why is this a L'Hopital's rule form, but why is it even indeterminate? Isn't 0 times anything just 0? Well, remember, none of these things are ever actually get to 0 or infinity. The x just gets smaller and smaller and smaller, but never really makes it to 0, because that's how we evaluate limits. We never actually arrive at the point that we're approaching. And of course, ln x, it just keeps getting larger and larger and approaching infinity. So the question is, which thing is going to, these two forces are kind of tugging on each other in opposite directions. One of them wants to make it 0, one of them wants to make it infinity, and which one of them is going to win out? We don't know. That's why it's an indeterminate form. So now, why is this L'Hopital's rule indeterminate form? The answer is because I can say that this is equal to the limit as x approaches 0 plus of, I can say, of ln x over 1 over x. In other words, multiplying by x is the same thing as dividing by 1. It's dividing by x's reciprocal. So that's what I've done here. What we can see now is that ln of x is, as x approaches 0, is growing to negative infinity, and 1 over 0 is going to grow to positive infinity. So I in fact do have an infinity over infinity form. And by the way, any combination of positive and negative infinity is okay. Negative infinity is still considered infinity for the purpose of it's an infinity type of expression for a L'Hopital's rule. So, negative infinity over infinity is still L'Hopital's rule for the same reason. So anyway, what we have here is we now have infinity over infinity. So by L'Hopital's rule, we can take the derivative of the top and the bottom, and this is going to be 1 over x, that's the derivative of ln x, and the derivative of 1 over x is negative 1 over x squared. So this is just to write it a little bit more clearly, this is going to be x to the negative 1 over negative x to the negative 2. That becomes, once we simplify that using the laws of exponents, that's going to be negative 1 minus negative 2 is positive 1. We still have the minus sign in front, so that's going to become the limit as x approaches 0 plus of negative x, which is equal to negative 0, which is just 0.